Good morning. We're getting into probabilities, and let's talk about how to determine how many ways there are to do something. When we talk about counting methods, that may sound almost silly. After all, you've been counting since you were 3 or 4. But we're talking about determining how many possible combinations there are in order to have, say, rolling some dice or tossing coins or even choosing a meal from a menu. Let's say that we want to toss 2 coins. So when we toss these 2 coins, there's only 2 ways a coin can land, either heads or tails. So if we only toss 1 coin, we're going to get a head or a tail. So 1 coin. Now, since we're going to allow repetition, but these are going to be independent events, then if we toss 2 coins, the first one could land on a head or a tail, but the second one could also land on a head or a tail. So if the first one lands on a head, the second one could be a head or a tail. If the first one lands on a tail, the second one could still be a head or a tail. So this actually gives us 4 combinations, and frequently they'll set this up as a tree. So the first one could land on a head or a tail, and the second one could land on a head or a tail, regardless of how the first one landed. So we have to make a branch for the first one landing on a head, and then the second one could be a head or a tail. Or the first one could land on a tail, and then still the second one could be a head or a tail. So there's actually 4 possible outcomes here. We could have a head-head, as would be denoted by this. We could have a head-tail, which would be going up here and then going this way. Or if we go to the tail first, we could have a tail-head or a tail-tail. Now notice here that repetition is allowed. You can have 2 heads or 2 tails. So there are 4 possibilities. Now the thing is, when you do something with 2 2s, you always end up with a 4. 2 plus 2 is 4. 2 times 2 is 4. 2 raised to the 2nd power is 4. So we know we did 2 coins, each of which could land 2 ways, and we ended up with 4 possibilities. Would we get this by adding them, multiplying them, or raising one to another power? Well, let's go with 3 coins and see how that goes. If we have 3 coins, then if the first one lands on a head, all of these possibilities still hold true for the second 2 coins. So this could be a head or a tail, each of which could be a head or a tail. Or if the first one landed on a tail, we still have this whole entire branch. So the second one could still be a head or a tail, and the third one could still be a head or a tail. So now we've got a much better idea of how this is going. Notice now we've got head, 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 or head, head, tail, or head, tail, head, or head, tail, tail, or tail, head, head, tail, head, tail, or tail, tail, head, and tail, tail, tail. So now we have 8 possibilities. How do you get an 8 out of 3 2s? Well, you don't get it by adding them together. 2 plus 2 plus 2 would be 6. If you multiply 2 times 2 times 2, you get 8. Or another way to look at this would be to raise 2 to the 3rd power, which is exactly the same as 2 times 2 times 2. So that would actually give us 8 also. Now, can you picture that if we had 4 coins, if we did a 4th toss, if the first one landed on heads, we would have all of these possibilities for the next 3. And if the first one landed on tails, we would again have 8 possibilities for that. So every time we add another coin, we multiply, we double the number of possible ways to get combinations. In other words, if we had 4 coins, I'm going to spread this out. The first one could be a head or a tail. The second one could be a head or a tail. The third one could be a head or a tail. And these are independent events, meaning that the way the first coin lands has no effect on how the second coin might land, and so on. None of these coins influence any of the other coin landings. So this would be 1, 2, 3. If we add a 4th coin to the mix, we add another head, tail, head, tail, head, tail, and so on and so forth. If I can squeeze these in. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 ways. So if we take 2 coins and raise that to the 4th power, that's going to be 16. Now it's also true that 4 raised to the 2nd power would be 16. But when we did the 3 ways, taking just this part, this would be how 3 can land. 3 coins resulted in 8 ways to do it, and 3 squared would have been 9. 2 cubed is 8. So if you have exactly the same number of possible ways for something to land, you take the number of ways it can land times the number of times you're going to do that. Another way to do it is to simply multiply these out. There are 2 possibilities for the first one to land, 2 possibilities for the second one, 2 for the third, and 2 for the fourth. And if you multiply those, you get 16. What if we had, what if we wanted to roll dice? Now there are 6 ways to land. So if you have only one die, there are 6 possibilities. If you have 2 dice, the first one could land any of 6 possible ways, right? The second one could land any of 6 possible ways. And so on. So how many are we going to end up with down here? There's going to be 6 at the end of each of these 6. So there's going to be a total of 36 ways to do it. If we roll 3 dice, we're going to have 6 ways for the first one to land, 6 ways for the second one to land, and 6 ways for the third one to land. Remember that these are independent. One has no effect on how the next one is going to land, and repetition is okay. In other words, we could get a 1-1-1 combination, and that would be fine. So 6 times 6 times 6 times 6, 216 ways to do that. And at this point, trying to do it by drawing a tree or listing all the possibilities is kind of ridiculous. So we need to have this multiplication way of trying to calculate it. What if we had choices from a menu where we had to choose between one of 3 meats, one of 4 vegetables, and one of 2 desserts? Then we would have 3 possibilities for our meat and 4 possibilities for our vegetable. So each of these 3, if we choose chicken, we can still choose any of the 4 vegetables. And if we choose hamburger steak, we could choose any of the 4 vegetables. And if we choose, I don't know, grilled sirloin, we could choose any of the 4 vegetables. So 3 meats, choosing one of those, 4 vegetables, choosing one of those, and then 2 desserts. Well, that doubles that. 3 times 4 times 2 is going to be 24. There are 24 different meals you can have choosing between 3 meats, 4 vegetables, and 2 desserts. Makes the cafe line seem a lot better than usual, right? Okay, so when you have independent events, one does not have any influence on how the next one will land. Independent events where repetition is okay. You want to multiply the number of ways in each, the number of ways each can occur. That sounds good, doesn't it? So that's how we do the counting methods for independent events, and repetition is okay. Next, we'll try independent events where repetition is not okay. Okay? So I'll see you then. Bye.